Good afternoon, sir.
Very good afternoon to all.
So,
So in the last class, we were discussing negative clamper. I have started with negative clamper because positive clamper is the question number one. Question number one of your tute number third. So that's why instead of positive, I have taken negative clamper first, because when you will solve that question, a positive clamper will be automatically covered. So can you see the screen?
yes, so
Okay. So we have calculated up to almost 90% of this negative clamper was done. The main aim was to calculate the voltage on this capacitor and the polarity of voltage, that we have already done. So for a square, we for this negative clamper, unbiased negative clamper with input wave as a with square wave as an input with magnitude Vm and minus Vm. So the voltage on this capacitor will be Vm in this manner. Okay, and after that you can start your analysis in the same way like we used to do. That is for positive half cycle and negative half cycle. Okay, so I have
Good
written
morning,
it.
sir.
Good morning.
Good afternoon, sir.
Yeah, good afternoon. It is good afternoon.
Sorry, sir. Good afternoon. Good afternoon,
Good
sir.
afternoon to all once again. Okay, so now I am putting you all of you in the mute mode. You all know what happens when I left this option open. So if you have doubt, you can raise your hand. Okay, so the main task we have already completed, evaluating this VM for this given input wave, and this is the circuit. Okay, so after the charging of capacitor, the clamping action starts. Okay, so when you will notice that question number one of your tute 3. Okay, so I am talking about tutorial number 3. So question 1 and 2 are based on clamper. So they have given something like this. This is the input, and they have given positive clamper like this. Okay, so if you start your analysis considering that this is the only present wave, so the output will be wrong. Okay, because for the positive half cycle, plus will be here, minus will be here, and this diode will be off. Okay, so V out should be equal to V in. And for the negative half cycle, minus will be here, plus will be here, and this diode will be off, short circuited. So V out will be equal to 0. So no clamping action is happening. Basically, it is a clipping. Okay, because we have not considered the charging of this capacitor. So that's why you always assume one pre-charging cycle is given, and during this cycle the capacitor will charge, and you will then, after evaluating this thing, VC plus minus or minus plus, whatever is the polarity, then you simply start your analysis, okay, in this manner. Okay, so I have written here, so during the positive half cycle of input signal, okay, so during the positive half cycle, plus will be here on the top wire, minus will be at the bottom wire, and yes, Neelav.
सर ये जो ट्यूटोरियल 3 का जो फर्स्ट का बी पार्ट है सर, उसमें डायोड को बायस किया हुआ है सर। 5 वोल्ट की बैटरी के साथ, तो सर आउटपुट वोल्टेज कैसे होगा सर?
हाँ, वो तो ट्यूट में किया नहीं आपने वो? आपकी बैच कौन सी है?
सर किया था सर, पर
हम्म,
सर ME2
ME2।
सर
ठीक है।
उतना अच्छे समझ में नहीं आया सर, अगर आप थोड़ा थ्योरेटिकली बता देते तो।
अच्छा, आप हम ये कर सकते हैं, न्यूमेरिकल क्लास वीकेंड पे ले सकते हैं एक, सारी एमई बैचेस का। पता नहीं आपका कौन ट्यूट ले रहा होगा, तो आप लोग वर्कआउट कर लो किस टाइम आप चाहते हो, कौन कौन चाहता है, तो मैं ट्यूट सारा सॉल्व करा दूंगा एक्स्ट्रा क्वेश्चंस के साथ। ठीक है।
ओके सर।
और ये मैं कंप्लीट कर लूँ, फिर देखते हैं वो क्या, उसका भी देख लेते हैं एक बार। यस मयंक।
सर ये जो अभी MST हो गए हैं हमारे, इसके अंदर हमारी डेरिवेशंस भी आएंगी या फिर क्या स्केड्यूल है, एक बार
नहीं,
आप
वो तो
ब्रीफ कर सकते हैं?
मल्टीपल चॉइस होगा। शेड्यूल अभी कोई फिक्स नहीं है फर्स्ट ईयर का, क्योंकि काफी न्यू ज्वाइनीज भी है। और
यस
जो
सर।
होना है वो अभी जो सेकंड थर्ड फोर्थ ईयर का हो रहा है वो है 3 क्विज, मल्टीपल चॉइस क्वेश्चन, ट्रू और फॉल्स, फिल इन द ब्लैंक्स टाइप ऑफ क्वेश्चन है, एंड 2 आउट ऑफ बेस्ट विल बी कंसीडर्ड। ये स्ट्रेटेजी है।
सर तो फिर जो न्यूमेरिकल्स होंगे इनके लिए हमें करेक्ट आंसर ऑप्शंस में होंगे या फिर हमें सॉल्व करके भी दिखाना पड़ेगा या फिर?
नहीं, करेक्ट ऑप्शन। सॉल्व कैसे
ओके।
करोगे एमसीक्यू
हाँ
में,
जी।
सॉल्व कैसे
हाँ जी।
करोगे? जेईई का ऑब्जेक्टिव होता है ना,
हाँ जी।
वैसा
ओके।
होगा, या ट्रू और फॉल्स होगा या फिर इन द ब्लैंक्स होगा।
ओके सर, थैंक यू।
यस भावेश।
सर मेरा सर न्यू एडमिशन है सर, मेरी आज पहली क्लास है सर, तो मैं कैसे कवर करूं?
आप मेरा नंबर लिख लीजिए, आप मुझे मैसेज कर दीजिए।
यस सर।
I will forward you 7442084। I will forward you all the details and आप मुझसे, अभी तो 3 बजे तो मेरी मीटिंग है डिपार्टमेंटल फैकल्टीज की, ऑल ECD डिपार्टमेंट। यू कैन कॉल मी अराउंड 5:36 के अराउंड, आप मुझे कॉल कर लीजिए।
ओके सर।
ओके, नो प्रॉब्लम। और जो भी न्यू ज्वाइनीज है भावेश के अलावा, they can drop me a message. I will forward you the link of the study material and we can have then detailed conversation. ठीक है। Okay, so at present there is no such a plan of your MST. Dean office से अभी आना बाकी है, कब होगा कैसे होगा, and then information will be conveyed to you. So अभी revise करो हालांकि। Anyways, so we will continue with our discussion. Okay, so during the positive half cycle of the input signal, this is your positive half cycle, a straight line of magnitude Vm. So plus will be at the top wire, minus will be at the bottom wire. So you can see that at the end terminal, this is connected to this minus and the magnitude is Vm, and this P side of this diode is connected again to minus terminal of this capacitor. So it is like, it is this kind of situation, Vp is equal to Vn. Okay, and Vp minus Vn. Why this is the situation? Because Vp minus Vn is Vm minus Vm, that is equal to 0. So Vp is equal to Vn. This Vm is because of input signal and this Vm is because of capacitor. So diode will be off. At least Vp should be greater than Vn to on the diode. Okay, even though it is, we are considering ideal diode, so Vp should be greater than Vn to on the diode. So now what will happen? Diode will be in off state. You can remove the diode from the circuit. So this will be the equivalent circuit. Your input voltage source, a square wave generator, capacitor with voltage Vm, polarity is like this, and the external resistance R with V out is equal to V in minus Vm. Okay, so simply you have to apply KVL. So this V out will be combination of your input, given input voltage sources. So this is first component is Vn, and the second component is Vm. So this will be in plus form, the polarity is opposite, this will be in minus form. And putting the actual value, so Vin is equal to Vm. Okay, for the plus positive half cycle, Vin is equal to Vm, and this is Vm. So Vm minus Vm gives you 0. Okay, so for the positive half cycle, this will be your output, 0. Okay, now for negative half cycle, minus will be on the top wire, plus will be on the bottom wire. So you can see that diode will be off because in this case Vp minus Vn will be minus 2M. So N side is connected to positive and P side is already connected with negative. So obviously your diode will be off, and you can also calculate what will be the value of Vp minus Vn. So that will be minus Vm because of input signal and minus Vm because of capacitor. So that will be minus 2 times the Vm. So this will be your equivalent circuit. Now again removing the diode, and this equation is valid. V out is equal to V in minus Vm. The equation will not change, except that the value of V in is this time the value of V in is minus Vm. We are talking about the negative cycle. So value of V in is minus Vm, and this is the DC value stored onto the capacitor. So this is minus 2 Vm. So minus 2 Vm corresponding to minus Vm input. So you can see that the voltage swing difference between the top and the bottom value is, here it is 2 Vm. This is a small check at the last step. And again, the difference between the top and the bottom value, here it is 2 Vm. Okay, so you can see that I have already mentioned in the notes, or I might have told you that this diode will be only on once. And when this diode is on, this capacitor will get charged. After that, this diode is having no role in the circuit. So we want this diode just for this charging purpose. After that, you can all ignore this. Just you have to apply the network theorems. Okay, so this is the overall working of negative clamper. So one student has asked me that about the bias clamper. So positive clamper, now instead of taking a simple positive clamper, I am taking that biased positive clamper. So both things, biased as well as the positive clamper part, will be covered. So okay, so किसी को याद है क्वेश्चन क्या था? मुझे जहां तक याद है वी हैव, जितना मुझे याद है क्वेश्चन में input wave was a square with I think this was the input wave given, V in T plus 20 volt, and this is minus 20 volt, and circuit was something like this, a square wave generator with capacitor, diode now connected in opposite manner. So this is how you design positive clamper, just reverse the connection of the diode. And minus plus 5 volt was given, the polarity was something, I believe it was something like this, plus minus 5 volts, so plus minus plus minus plus, or it was like it was something like this. Anyways, the method applied on this circuit is valid on the opposite polarity also. So this is R, and across this R you have to measure V out. So this is biased positive clamper. Okay, and this bias source will be always in series with the diode. Polarity can be reversed, there is no problem, but this will be always across this diode. Okay, So if you follow this simply, that only this one waveform is given. Okay, so you can see that during the positive half, plus will be here, minus will be here. Okay, so this DC voltage source, okay, so this DC voltage source, the negative terminal is connected to P side, and here also you can see that positive is connected to N side, so diode will be off. Okay, so diode will be off, and when you will remove this branch, this will be the equivalent circuit. And initially capacitor is discharged, and discharged capacitor act as a short circuit like this. So V out will be turn out to be equal to V in. So this is wrong. Okay, you don't have to do that. So what you have to do actually, let me erase this. So what you have to do, you have to assume that one charging cycle similar to this wave was given before this input cycle. Okay, one time period with one time period T. Okay, so you can see that for positive half of the input cycle, or sorry, charging cycle, for positive half of charging cycle, plus will be at top wire, minus will be at the bottom wire. Diode is reverse biased, hence we will consider it as off. Okay, that's it. So no need to analyze it further. Okay, now come to this negative cycle. So for negative half of the input cycle, okay, and this magnitude is 20 in the negative direction. So now in this case, minus will be here for the top wire, plus will be at bottom wire. So this is the condition of the diode. This is your diode. So you can see that at P side we have minus 5 volt, and onto N side we have minus 20 volt. Okay, and these are negative voltages. Okay, so and minus 5 is greater than minus 20. This means that this means that voltage at P side is greater than voltage at N side, and this is the condition to get your diode in on state. So your diode will be on. So now what you have to do, when your diode is on, you replace your diode with the equivalent circuit. So minus plus magnitude is 20 volt. A capacitor, an on diode acts like a short circuit like this, and we have a minus plus 5 volt DC voltage source in series. Okay, like this, and we have some resistor. Okay, so we have to ignore resistor at this point. Okay, because we are interested in the voltage across this diode. So this diode is connected to this capacitor. So this capacitor is connected to minus 20 volt. This is because of V in. This left hand plate is connected to minus 20 volt, and this right hand plate is connected to minus 5 volt. So you can see what is the net voltage. Okay, let's assume that this is the left plate, this is the right plate. So net voltage drop across this capacitor VC is VL minus VR. Okay, so this is minus 20 minus of minus 5, that is minus 20 plus 5, this is minus 15. So this will be the voltage The magnitude of voltage is now not 20, it is 15, and minus to the left hand side, plus to the right hand side. Okay, also you can just apply common sense that this minus 20 volt, this will force the negative charge to accumulate on this plate, left hand plate, and as a result the same amount of charge should be accumulated on to the right hand plate. Okay, but again this right hand plate is connected to a negative voltage source of 5 volt value. So this 5 volt, what will it will do? It will try to store negative charges onto this plate. Okay, so this voltage source is trying to store positive charge onto the right hand plate. This is trying to store negative charges. So there we should take the difference of the voltages. Okay, so 20 minus of minus 5, and net will be minus 15. Minus is here, plus is here. It is obvious that this magnitude is greater, so minus sign will be prevail onto this left hand side, and onto the opposite side we have positive sign. So we have determined VC, the most important part we have done. It is very simple. Okay, now this is your circuit. This is your circuit, and capacitor is charged to 15 volts, and this was your diode with minus 5 volt DC source and a resistance in parallel to this branch, and you have to measure V out across this resistor. Okay, so now you will start your analysis like we used to do. So this is the given input signal. This is V in with plus 20 volt and minus 20 volt in the negative and positive direction respectively. And we will start with positive half cycle. So positive half cycle of input, and again you will see that now for both positive and the negative half cycle, this diode will be in off state. This means that after this charging, the diode will be always in off state. So again we will prove this. So for positive half of input, okay, plus will be at the top, minus will be at the bottom of this voltage source, and this is minus plus 5. Okay, so this combination of the input voltage sources, this is forcing your diode to be in the reverse bias state, negative connected to P side and positive, both this positive will add up, and positive is connected to N side. So diode is a reverse bias, and reverse bias diode is considered as off. So this is the equivalent circuit, 20 volt, because this is a straight line of 20 volt, capacitor with the voltage of 15 volt, and this diode is off, so we can remove the diode, and as a result this 5 volt battery source will be also disconnected from this circuit. So no need to draw this branch. You can just simply draw the resistance. VR will be equal to V out, that will be measured between point A and B, and simply you can see that V out is the combination of the input voltage source, so that will be V in. Now these are of same polarity, minus plus minus plus, okay, plus this and minus plus this, so V in plus VC. V in is plus 20, VC is 15 volt, and 20 plus 15 gives you 35. Okay, so you should have expected 40 volts if this 5 volt source is not connected. So this should be 20 plus 20, 40. Okay, but because of this 5 volt in this manner, minus on the top and plus at the bottom, 5 volt, we have lost the 5 volt. Okay, so the output is 35 volt. So for this input, VT, we have output. If this is 20 volt, the output value of output is 35 volt. Okay, 15 more than 20 up to T by 2. And after that, you will do the same kind of analysis for negative half cycle. So for negative half cycle, okay, for negative half cycle, minus will be on the top wire, plus will be at the bottom wire, and this is minus plus 15 with your diode like this, and this is the resistance RV out. So again, you can see that this is N side, this is P side, the magnitude is 20. So this is minus plus 5. So onto the P side, this is, sorry, this is not P side, this is the P side. This is the positive terminal of battery. This is the P side. So onto the P side, we have net voltage. This is 20. So this is P side. So we have plus 20 minus 5, that gives you 15. And onto the N side, we have plus 15 because of this capacitor. So because of this, this is because of input. This is because of DC source. And this 15 is because of capacitor. So condition is Vp is equal to Vn. So again, this condition is equivalent to the reverse bias state. So diode will be off. And you can always remove the off diode from the circuit. So removing it, deleting the entire branch. And now you can simply write V out will be equal to, again the equation will be same, V in minus, now this time plus Vc, and the magnitude of V in is minus 20, Vc is 15 and minus 5 volt. So now instead of 0 you are getting minus 5 volt. So for this minus 20 volt, you will get minus 5 volt. And the short check, just add the positive side value and the negative side value. 20 and 20 gives you 40. Okay, similarly 35 on the positive side, 5 to the negative side, so 35 plus 5 gives you 40. Okay, so this is how you can ensure that your answer is correct. 40 here, 40 here. Okay, and if you remove the bias source, the output will be something like this. This will be 40, this will be 0. Okay, and when you have added in this polarity, so what it is doing, it is forcing this output waveform to lower down by 5 units. So as a result, this is the output waveform. Okay, so we have covered both the positive clamper and the bias part. Both things are covered in this. Any doubt in this? Any students having any doubt in the clamper part? I have covered the positive and negative, both the clampers. So from my side, this is over. Now it is, now you should practice more and more questions. Okay. In Qt also we have 3 to 4 questions, so please practice it. And you can ask me in free times whenever you have some doubts. Okay, so now we can start our new topic, and the new topic is Zener diode. So I have to open. Yes, Chirag.
Sir, I just have one for this diode portion. Clamping diode is used. This clamping diode is used to increase the voltage. Like for certain sections, used to increase the voltage.
No, diode is used to charge the capacitor. That's it.
Sir, can you go to the previous slide? So for this section, in this the positive half of the input diode is in off state. No, previous one. So for this section, diode is in off state. So when we draw the graph, it's actually
you don't have the
not sure. It's actually
you don't have to draw the graph for this charging cycle. Again, I am saying you will end up in interpreting the wrong output. You have to first this is the charging cycle. That is what I am saying again and again. This is your given input, okay, but you have to assume that one pre-charging cycle was given, and you have to just determine the voltage across this capacitor whenever the diode is in on state. The diode will be on either in the positive or negative state. So you have to first figure it out in which cycle it will be in on state, and what will be after that, what will be the voltage, this thing.
So for if the diode is off state in the positive half, like if diode is off actually, then how are you supposed to draw the graph? That I'm having confusion.
So that's what I am saying, that you don't have to draw a graph for this cycle. I have not.
If it is off, no need to draw.
You see, this slide is talking about this charging cycle. Okay.
Yes, sir.
So can you see? You can see that even for positive half or for negative half, I have not drawn any graph. You don't have to draw any graph for this charging cycle. I have assumed it. You don't have to draw.
Assumption.
Yeah, assumption. No, it is actually given. Actually, in literature, when you will read Boylsted thoroughly. Okay, so but you have to read Boylsted. Okay, now students don't read a book thoroughly. So they, in 1 or 2 questions, they have said that before giving the input cycle, one cycle is given such because we want this capacitor to charge up to a certain value VC. Okay, and after that they have written that we will not write this again and again. You can in the rough part you can evaluate this, and then after determining this value, you solve like this in this manner. I have drawn. So now for you see, for positive half of input, I have determined the output voltage 35. This is my positive half. And then I have drawn the graph for this positive half. Okay, so before that I have not drawn any graph. This cycle was just to determine the voltage across this capacitor. That's it. Either plus minus in this way or minus plus. Okay. एक बार बॉयलस्टेड पढ़ना, क्लैम्पर के सॉल्व क्वेश्चन है, उसमें आप देखना, उसमें क्लियरली लिखा है, और बार बार वो नहीं लिखेंगे ये चीज, आपको भी लिखने की जरूरत नहीं है रफ में, आप भी ये लिख सकते हैं वहां पे. खैर एमसीक्यू में तो कोई लिखना भी नहीं है आपको मल्टीपल चॉइस क्वेश्चन में, बट थ्योरेटिकल में आप लिख सकते हैं कि because of this combination the charge on the voltage drop on the capacitor will be this and this will be the polarity, and then you can start your analysis in this way. Simple. वो तो मैं आपको समझाने के लिए इतना डिटेल लिख रहा हूँ, ये इतना डिटेल में आपको समझाने के लिए लिख रहा हूँ, ठीक है. And we have yes चिराग, क्लियर है?
Clear, sir.
ठीक है. And we have then Ayush. Yes, Ayush.
सर वो जो अभी आपने क्वेश्चन करवाया था उसमें हमारा लाइक एक बार इससे नेक्स्ट स्लाइड,
यही था स्टार्टिंग क्वेश्चन वाला बायस.
हाँ मतलब बीच में सर आपने वो लिखा था ना एक कैपेसिटर की वजह से हमारा एन साइड जो हमारी
ये लीजिए।
हाँ यस यस
हम्म।
सर, जो ये 15 इधर है, ये हमारा कैपेसिटर की वजह से लाइक आया है।
ये राइट हैंड साइड पे,
यस सर यस सर।
हाँ यस, दिस ये कैपेसिटर है, इस पे 15 वोल्ट आ गया। पोलैरिटी कैसी है, माइनस लेफ्ट प्लेट पे है, प्लस राइट प्लेट पे है, तो ये उसकी
यस
वजह
सर।
से। ठीक है, यही क्लैंपिंग का फंडा है, मैंने पहली स्लाइड में लिखवाया था कि दिस आफ्टर गेटिंग चार्ज दिस विल एक्ट एज अ डीसी सोर्स। हम उसको डिस्चार्ज होने नहीं देंगे बिकॉज वी आर इंश्योरिंग दिस कंडीशन 5 RC, ये कंडीशन में इंश्योर कर रहे हैं। तो आप ये हम बार बार ये लिखने की हर क्वेश्चन में जरूरत नहीं है कि T/2 इज लेस देन 5 RC सो इट विल नॉट गेट डिस्चार्ज।
ओके सर।
ठीक है,
यस सर।
and we have one more student, Vansh. Yes, Vansh.
सर मुझे एक्चुअली पूछना था कि बुक्स कौन सी आपने रिकमेंड करी थी?
मैंने बॉयस्टेड सॉफ्ट कॉपी सारे GRs को फॉरवर्ड कर रखा है।
ओके सर।
ठीक है, एंड उसके हमें करीब BJT और मैक्सिमम ओपैम्प ऑपरेशनल एम्पलीफायर तक जो चैप्टर है वहां तक हमें वो बुक रेफर करना है। उसके बाद डिजिटल के लिए दूसरी बुक है, दो वो भी मैं आपको फॉरवर्ड कर दूंगा जब डिजिटल पढ़ेंगे।
ओके सर।
ओके, सो नाउ लेट मी, ओके और है अभी। यस कार्तिक।
हम सर वो चैप्टर बता दो जहां तक हमने रेफर करनी है वो बॉयस्टेड वाली बुक।
अभी तो सेकंड वाला करना था, थर्ड सेकंड थर्ड और BJT के 2 चैप्टर जो जो हम पढ़ा रहे हैं उसके वो स्पेसिफिक मतलब ऑलमोस्ट वो है। 1 मिनट फिर मुझे ओपन करने दो, मैं शेयर करता हूँ, प्लीज वेट।
ओके सर।
Okay, so we have started with this is can you see the screen, book PDF of book? Mute.
Yes sir.
Okay.
Yes,
Yes,
sir.
So chapter 1 was like introduction, semiconductor, covalent. So this was a kind of a recap, N-type, P-type material, semiconductor, diode. So this is the main part, ideal versus practical. Okay, this is 1.5 onwards. Okay, and this is the topics which is expected that you have studied during your +2. So this N-type, P-type material, because diode is formed by N-type, P-type material, and then semiconductor diode, ideal versus practical. So this is the main starting point, then resistance level, capacitance, reverse recovery time, up to 1.11. And then this is small topic. I always forgot this. Okay, so this is the diode specification sheet. So whenever you purchase a diode, any diode, so this specification sheet about its the forward voltage, maximum forward current, reverse saturation current, peak inverse voltage, everything is given, and this is its specified limit is mentioned over there, so that you can operate it properly. You should not operate it beyond this the given specification. So you have certain design specifications, so you can choose the diode accordingly based on your specification. So these are some simple things up to 1.12, and today I was going to start this Zener diode topic. Okay, so you can avoid this diode testing, LEDs, this diode notation, this kind of things can be avoided. So main is up to 1.12, and then I was going to start Zener diode today, and then we after completing diode, what we have done, this load line analysis, series parallel configuration, and I don't remember exactly, but I have given you the example of OR gate. Okay, so and
Yes, sir.
and OR gate examples are given. So I have
Yes, sir.
explained you the OR gate and ask you to refer the AND gate. Okay, कुछ practice आपको भी करनी पड़ेगी. And then we have done this half wave rectification, full wave rectification, and clipper. And today itself we have completed the clamper part. And this is again the Zener diode part. Okay, you can avoid this 2.10 network with DC and AC source. So after clamper, you can jump to this Zener diode part. And this is basically the application of Zener diode as a voltage regulator. So I have planned to cover this the properties of Zener diode and its application into one single lecture. That's why I have avoided. Yes, please.
सर अभी अगर एमएसटी होंगे तो वो कहाँ तक आएगा उसमें सिलेबस?
ये मैं कुछ नहीं बोल सकता. वी हैव 6 फैकल्टीज. वो सारा मीटिंग में डिसाइड होता है. मैं यहाँ बैलेंटली कुछ भी कमेंट नहीं कर सकता बिफोर कंसल्टिंग. मतलब कोई भी फैकल्टी ऐसा नहीं करेगा.
एंड सर एंड सेमेस्टर में कहाँ तक जाएगा?
एंड सेमेस्टर में इसमें जो है आपको बाइपोलर जंक्शन ट्रांजिस्टर एंड कुछ पार्ट डीसी बाइसिंग का, पूरा नहीं, कुछ पार्ट. ठीक है, यहाँ तक है, चैप्टर 4 तक है.
ओके सर. और
एक ये चैप्टर 11 ओपेम्प भी है, बट आई डोंट नो व्हाट वी हैव टू डू अबाउट इट. जनरली ऑपरेशनल एम्पलीफायर बहुत छोटा टॉपिक है, बहुत शॉर्ट टॉपिक है, बहुत इजी टॉपिक है. तो रेगुलर में तो चैप्टर 4 तक एट मैक्स यू कैन हैव दिस चैप्टर 11. ओके, बस इस बुक का इतना ही रोल है और इससे ज्यादा रोल नहीं है इलेक्ट्रॉनिक्स में. उसके बाद दूसरी बुक मॉरिस मैनो आएगी जहाँ पे हम डिजिटल पार्ट पढ़ेंगे. ठीक है?
ठीक है सर.
यस चिराग.
सर ये बुक बीजेडी तक थी ना? बीजेडी तक.
हाँ, ये है ना बीजेटी चैप्टर 4. चैप्टर
यहाँ तक हमने यूज करी है.
बीजेटी दिस इज द कंस्ट्रक्शन, इंट्रोडक्शन, डिफरेंट कॉन्फ़िगरेशन. जैसे डायोड के कॉन्फ़िगरेशन थे, रिवर्स बायस, फॉरवर्ड बायस, वैसे इसके कॉन्फ़िगरेशन है. एंड देन बाइसिंग, डीसी सोर्सेस को अलग अलग तरह से लगाना. सो दिस इज डीसी. एसी एनालिसिस अभी नहीं करना है, डीसी तक है, चैप्टर 4 तक.
ओके सर.
सो ये हो गया.
तो बुक का नाम क्या है, फिर से बता देंगे सर. सर बुक,
एक मिनट, मैं फ्रंट पेज पे ले जा रहा हूँ. दिस इज द बुक and the soft copy is already shared by me. I have already shared the soft copy.
Sir, we'll share the link in the mechanical room.
Okay, thank you. ठीक है. So electronic devices and circuit theory, Robert Boylsted and L. Nashley. Boylsted के नाम से मिल जाती है. This Boylsted word is famous. And the publication क्या है ये? Many versions are available. The SPSN publication. So many versions are available. I am referring 11th version. 7th भी है, 10th भी available है. Almost same है सब. ठीक है. Okay, so the next topic is Zener diodes. So properties of Zener diode and its application I will be covering in the subsequent lectures, and then we will start BJT. So Zener diode, it is a special type of diode. Prakul, do you have any doubt? Yes, Prakul.
हेलो सर, आवाज आ रहा है?
हाँ प्रकुल बोलो.
सर एक सेकंड, वो पीछे जाइए जहाँ पे वो हमने वो इंडिविजुअल हाफ साइकिल्स का निकाला था.
ओके, मुझे फिर लेट मी ओपन दिस. एक मिनट वेट करो, वो मैंने क्लोज कर दिया है, वो दूसरा स्लाइड था, मैं उसे ओपन कर रहा हूँ.
सर जो जैसे हमने इसमें इंडिविजुअल हाफ साइकिल्स का निकाला था, तो सर इंडिविजुअल हाफ साइकिल्स में तो वो हमारा डीसी वोल्टेज नहीं सप्लाई हो रहा है इनपुट।
स्क्वायर वेव देते तो वो डीसी हो जाता है, यही स्क्वायर वेव की सिंपलिसिटी यही है। वो
सर तो अगर डीसी है तो सर वो कैपेसिटर उसको अलाउ कर देगा?
जब एकदम क्या होगा एक्चुअल में, एकदम से स्टेप होगा ना, वोल्टेज राइज होगा तो करेगा वो, उसके बाद वो अपनी मैक्सिमम वैल्यू तक, क्योंकि वोल्टेज जीरो से राइज हो रहा है ना, जीरो से फिर ऊपर जा रहा है, फिर मैक्सिमम से फिर जीरो आ रहा है, जीरो से फिर मिनिमम जा रहा है, सो इट विल अलाउ।
ओके सर।
पोलैरिटी चेंज हो रही है, सो चाहे वो साइन हो, ट्रायंगुलर हो, कुछ भी वेव हो, तो वो करेगा, नो प्रॉब्लम। Okay, so time is 1:46, almost up. So we will start Zener diode from tomorrow. And जो भी नए स्टूडेंट है आप प्लीज मुझे व्हाट्सएप कर दीजिए, और शाम को आप मुझे कॉल कर सकते हैं, तो हम डिस्कस कर लेंगे कैसे करना है। सो हैव अ नाइस डे। अनुराग, हाँ जी अनुराग।
सर
यस अनुराग।
गुड आफ्टरनून सर।
Good
सर
afternoon.
मैं नया स्टूडेंट हूँ सर, आज ही ज्वाइन किया है, तो रिकवरी एलएमएस पे हो जाएगी पूरी?
हाँ एलएमएस पे भी हो जाएगी, और हमने जो भी यहाँ पे पढ़ा है उसका सारा रिकॉर्डेड लेक्चर्स भी है। तो आपने मेरा नंबर नोट कर ही लिया होगा।
नहीं सर, मैं लेट हो गया था एक्चुअली, लिंक में कुछ डिस्टरबेंस आ गया था, तो मैं थर्ड
ठीक है,
ईयर में
तो
चले
नंबर
गया था
नोट कर
एकदम से।
लीजिए 7800
यस सर।
7800 420 845।
सर आपका नाम क्या है?
डॉक्टर सुमित व्यास।
थैंक यू सर।
So you can drop me a WhatsApp message, and after 5:30 you can call me. So I will provide you all the link of the material.
थैंक यू सर। थैंक यू।
Okay, see you tomorrow. Have a nice day. और भी था कोई? अंशित। Yes अंशित।
सर इसमें इनपुट वोल्टेज हमने जो कैपेसिटर की वोल्टेज थी वो इनपुट के इक्वल ली।
नहीं, इनपुट के इक्वल नहीं ली। अगर कोई डीसी सोर्स नहीं है तो वो इनपुट के इक्वल ही चार्ज होगा, क्योंकि डायोड शॉर्ट सर्किट हो गया और डायरेक्टली वो कैपेसिटर इनपुट से कनेक्टेड है। और जब 5 वोल्ट बायस लगाया तो वो 5 वोल्ट की पोलैरिटी रिवर्स थी इनपुट से, तो उसने पूरा चार्ज नहीं होने दिया, तो 5 कम चार्ज हुआ वो।
जब फर्स्ट साइकिल हमने लिया, जब
फर्स्ट में तो
पहला
फिर
साइकिल,
फर्स्ट में तो चार्ज ही नहीं होगा वो, सेकंड में चार्ज होगा वो, नेगेटिव वाले में होगा।
जब नेगेटिव हमने फर्स्ट पॉजिटिव लिया था।
चार्जिंग साइकिल की बात कर रहे हो आप?
यस सर।
हाँ, तो पॉजिटिव हाफ में तो वो चार्ज ही नहीं होगा, डायोड ऑफ रहेगा। नेगेटिव में चार्ज होगा वो। नेगेटिव में डायोड, जब भी डायोड ऑन रहता है तब हमें निकाल इवेल्युएट करना है, जब ऑफ रहता है तब इग्नोर कर दो।
कैपेसिटर के चार्ज को
इग्नोर कर दो, कैपेसिटर चार्ज, हाँ इग्नोर कर दो, वो बहुत माइन्यूट अमाउंट में चार्ज होगा, उसका कोई सिग्निफिकेंस नहीं है। हमें डायोड जब ऑन होगा तब हमें उससे मतलब है। ठीक है, तो एक बार पढ़ो, बॉयलस्टैट पढ़ो, एक रिकॉर्ड।
तो सर वो इनपुट के इक्वल तो नहीं होता ना हमेशा?
अगर कोई एक्सटर्नल डीसी वो सोर्स नहीं है तो इनपुट के इक्वल होगा, अदरवाइज डिफरेंट होगा थोड़ा सा, दोनों का कॉम्बिनेशन होगा, प्लस माइनस होगा।
ओके।
यस नीलम।
हाँ सर, जैसे सर आपने कैपेसिटर पे अलग वोल्टेज निकाली थी ना सर 15। सर मैम ने सीधा सीधा केवीएल लगा के फिर वोल्टेज 5 निकाली थी सर,
अब मैं
और
क्या
फिर उसको
कमेंट
पॉजिटिव
करूं?
साइकिल में रख के 5 निकाली थी। तो सर ये मेथड सही है सर?
भाई मैं तो ऑब्वियसली मैं गलत क्यों पढ़ाऊंगा आपको?
नहीं सर, वो
there are multiple methods as far as answer is same, all are valid. उनका भी आंसर सेम आ रहा था क्या? अगर उनका आंसर ये नहीं है तो फिर कुछ
ये सर भी 35 और 5 वोल्ट्स आ रहा था।
देन वो भी सही हो सकता है। देयर आर मल्टीपल मेथड्स। एक टीचर कोई एक ही स्ट्रेटेजी फॉलो करेगा, यू आर फ्री टू अडॉप्ट एनीथिंग। आप अपना भी कुछ इनोवेटिव दूसरा कर सकते हैं। ओके ओके, सो नाउ आई हैव टू एंड दिस मीटिंग, दूसरा टीचर वेट कर रहा है। हैव अ नाइस डे, सी यू टुमारो।